Hey, welcome to this tutorial. I'm glad you came. Alright, so in the last tutorial we talked about reading voltage at the digital pins, and it was either on or off. Well, and I mean that can be extremely useful, but a lot of times you want to know more than just that. What about a question like, well, how bright is the light? Or how fast is the satellite moving? So these types of questions are often analog. They cover a large range of values, not just like on and off. So the Arduino handles analog inputs with 6 dedicated pins labeled A0 through A5, and these pins have access to the analog to digital converter on the Arduino chip, which takes the range of input values and then it creates a digital version by cutting up that range into tiny little pieces. And all this is handled behind the scenes. I mean, all you have to do is write some really simple functions and you pretty much get what you need. So we're gonna deal specifically with the analogRead function. We'll also be working with serial communications again, and you'll find with a lot of the tutorials throughout this, we're going to be using serial communications quite a bit. So you'll get very familiar with that, and also with the digital and analog reading. All right, so let's go ahead and jump in. All right, for this circuit, you're going to need an Arduino board. I've got the Arduino Uno here. You can use any clone you want. I do recommend, however, for these tutorials, sticking with the original Arduino just so you know you're on the same page. You're also going to need a potentiometer. I have a 10K potentiometer. It doesn't matter what resistance level yours is. And a potentiometer is just like like a volume knob on something is what you would expect there. And you're going to need at least 3 jumper wires, and then you'll also need a solderless breadboard, and then you're going to need a cup that you can juice lemons into. Alright, so here's our schematic. So you can see this is a really simple circuit. If you adjust your breadboard and your Arduino like we have in the schematic, then we'll be talking the same language as we go through this whole sketch. So you see the potentiometer, like the part that you turn, is pointed away from the Arduino, and 5 volts we have connected to the left side of the potentiometer. Ground is attached to the right pin of the potentiometer, and then the center pin of the potentiometer, that is what goes to A0, which is the first analog pin on your Arduino. So what's happening here is the potentiometer is acting like a voltage divider. So on one end of the potentiometer you've got 5 volts, and on the other end you have 0. And when you adjust that knob, the center pin is going to change all the way up from 5 volts down to as low as 0 volts. So as you adjust that knob, you are adjusting the amount of voltage that's going to be seen at that center pin, which ends up being, what we have on our Arduino attached at A0. Okay, so that's essentially how this is working. So in this sketch, what we're interested in the level that that knob is turned. That's what we want to know. We don't want to know, is it 5 or is it 0? We want to know, well, what is it in between? So let's go to the sketch and check it out, how we can do that. So go ahead and open up your Arduino IDE and then go to File, Examples, Basics, analogRead Serial. Alright, so we've got our blocks of code. The first block of code we're going to look at is the comments. So here, the comments briefly describe how the circuit is set up and what the program's going to do. And then it also lets us know that this code is in the public domain, so we can use it however we feel like. And that's it for the comments. Again, good habit to always read the comments when you're opening up a new program. Okay, so nice, short, concise. We move on. We notice that there is no block of code to initialize or declare and initialize variables, and we obviously don't have to do that. But just note it in your head. Okay, you're not going to see it in every program. But the next block of code is very typical, and it's the void setup block of code. The only thing we've got going on in here is the begin function from the serial library. And again, we talked quite a bit on this last tutorial, so I'm not going to cover it too much. But if you're wondering about it, you can revisit the last tutorial. We'll talk about it talks about serial begin. So again, we're using that 9600 as the argument, which is the baud rate, and that's all we have to do in setup. And again, we're starting serial communications here because later in the program we're going to want to know the value that our potentiometer is set at. So let's take a look at the loop function. Again, loop is going to run over and over and over again, and it's going to contain the code that's pretty much the meat and potatoes of the sketch. Okay, so let's come to this first line of code here, and you'll notice that it's very similar to the last tutorial first line of code, the digital read tutorial. And all we've really exchanged here, instead of using the digital read function, we're going to use the analog read function. But let's go ahead and start at the beginning of this line of code. So just straight up, we can tell that there is a variable declaration. We've got int, that's integer. We see that it's orange, it's a keyword. Then we have the name of the variable that we're declaring, sensor value. Wonderful name there, very specific. And we initialize it, we're setting it equal to, initializing it, to the output of the analog read function. So what is this analog read function? Well, it's a lot like digital read, but it's much cooler, in fact. Analog read is going to read the voltage that's being applied at one of the analog pins, and it's going to return an integer value. So the analog pins, those are A0 through A5, so that's what you can put in those parentheses. That's the argument that you pass to the analog read function. And then that integer that it returns, well, it's not going to be the voltage. It won't be 0, 2, 3, 4, 5. It's actually going to be an integer value range from 0 to 1023. I know, strange range. So let's throw some numbers out here. If you're applying 0 volts at, let's say, pin A0 that we've got in this example. If you're applying 0 volts to pin A0, so you've got it connected to ground, the integer that analog read will return is the number 0. And if you're applying 5 volts at pin A0, the integer value that analog read is going to return is going to be 1023. Now if you're half of that, so if you've got 2.5 volts applied to analog read, guess what? You're going to be at a number somewhere between basically the half of 0 and 1023, which is like 511. It's not going to be 511 and a half, because again, it returns an integer value. So it's going to be somewhere in there. It's going to cut 0 to 5 volts up into 1023 discrete steps, and that's the integer that it's going to return. Let's think about our circuit for a second here. We've got our potentiometer, the middle pin, hooked up to pin A0. So when we and then the left side and the right side, the left side's hooked to 0 volts and the right side is hooked to 5 volts. Basically what we've got here is a voltage divider. So as we adjust that potentiometer, the amount of voltage going out that center pin is going to change. So we can have it all the way down to 0, we can have it all the way up to 5, and then we can have it anywhere in between. And where we have that positioned is going to affect the voltage being applied at pin A0, and thus it will affect the number that analog read returns and gets initialized to the sensor value variable. Okay? So I know that was a lot to say there about this function, but I think you get it. So what's going to happen in this line of code? Well, sensor value is going to get assigned whatever voltage is currently being applied at the analog pin that we've applied, which is A0. All right, so what do we want to do? We got that value. Now what do we want to do with it? Well, let's check it out. Let's send it to the computer so we can visually see it. So how do we do that? We use the print line function from the serial library, and we pass it the variable sensor value. That's the one that we just declared and initialized, so that we can see that value, the current setting of our potentiometer. So what we'll have to do is open up our serial monitor window, and then we'll see those values start scrolling down the screen. And then finally, we delay 1 millisecond. That allows stability for reading. So if you're turning that knob really fast, it's going to look every millisecond. It's going to take that value and return it. All right, and then it just goes up to the top again. It's going to look at that, look at the current voltage. It's going to pass that to the serial print line, and it's going to print that again. And it just does that over and over and over again. So it kind of gives you a dynamic readout of where your potentiometer is set. So let's go ahead and verify this sketch, and we'll upload the code, and then let's monitor the serial monitor. So we'll go to serial monitor, open it up, and you can see here's these numbers already coming down. So I'm about mid position. So I'm going to turn my potentiometer all the way right. You can see I maxed out now and I'm at 1023. So now we know 5 volts is what corresponds to 1023 at pin A0. And now I'm going to turn it just all the way left, and it goes down to 0. I mean, that's, you can see here's about midway, there's about 500. So you get the idea here. So now as I'm adjusting this potentiometer, I'm getting this large range of numbers. Now that is pretty much analog read in a nutshell. I hope everything made sense to you. If it didn't, please let me know and I'll make some changes. Now, you can imagine there are a lot of applications for the analog read function. So I'm just using our simple potentiometer here. You know, you could imagine setting ranges. So if it's all the way to the left, like say the value that analog read returns is between 0 and 500, then we want it to do this. If it's between 500 and 700, do something else. And then if it's between 700 and 1023, then go walk the dog or whatever. You know what I'm saying? Now, you'll find that lots of sensors out there, the way they convey information is by adjusting voltage. And this analog to digital converter is exactly how you're going to get that information from the sensor to do really cool things. So thanks so much for listening to this tutorial. I can't wait to see you in the next one. And please do the try it on your own challenge for these lessons. It's really going to help you understand. Have a good one. See you next time.